This is part B of the same question. The network of resistors in figure 6.1 is connected to a battery. I'll just write Jan07 in here again. One terminal of the battery is connected to B and the other battery terminal is connected in series with a 5 ohm resistor to the point D of the network as shown in figure 6.2. The battery has an EMF of 12 volts and an internal resistance of 1 ohm. So it asks you to calculate the total external resistance now connected to the battery. So that means you're not including, in the calculation we're about to do, we're not including the 1 ohm here. It will be needed in the next part of the question, but it's not needed right now. So if we have a wee look to see what we've got, I'm just going to start with the parallel bit. So if we start at B there, you can see that you've got a 2 and a 4 ohm resistor. Sorry, I'm just going to check that. Yeah, a 2 and a 4 ohm resistor here. Just if you check the current goes around to B and then it splits up like that and joins back together at D. So we're going to take these two lines in parallel with each other. So I'm going to draw my B there and it's got a 2 ohm resistor and a 4 ohm resistor. And then that's in parallel with, if I just go back up here again, the 3 and the 9. So 3 and 9. And then, so then the current is split here, joined back together here, and just on round here to the 5. So it's in series with the parallel combination. So I'm going to redraw that beside it. And that's our calculation that we have to do. So our two lines here in our parallel bit are going to be, I'll just ring the parallel bit here, are going to be 6, it's like a 6 ohm resistor in parallel with a 12 ohm resistor. And so we're just going to calculate that total there. RT of the parallel bit is equal to 1 over 6 plus 1 over 12. It's 1 over R parallel actually. It's 1 over 6 plus 1 over 12, which is the same as 2 twelfths plus 3 twelfths, 1 twelfth, which gives you 3 twelfths. So the R parallel bit is 12 over 3, which gives you 4. But then the total is the addition of those two. So we've got 4 plus the 5 that's sitting in series with it. And that gives you a total resistance of 9. Total resistance of 9 ohms. So then it says calculate the power dissipated in the 5 ohm resistor. So we're going to use the equation P is equal to I squared R. But our first job is to calculate I. And when we calculate I, we have to include our 1 ohm resistor from the internal resistance of the battery with that total resistance. So the total resistance in the circuit is actually 10. It's the 9 ohms we've already calculated plus the 1 belonging to the battery. So it's 10 ohms. And we're going to calculate I as V over RT. And V is 12 volts over RT is 10, which gives you 1.2 amps. And then we're ready to do our power calculation. P is equal to I squared R. And that's going to be equal to 1.2 squared multiplied by 5, and that gives you an answer of 7.2 watts.